Hello everyone, welcome to another video in the Transformer series. Today we're going to be looking at multi-headed attention. So let's start. Before going to multi-headed attention, I'm going to give a quick recap of the plane attention that I explained in the previous video, and then we will go on to derive the multi-headed attention from this. So let's start. Now let's say we want to pass let's say I give you this sentence and we have an initial representation for this. Let's consider everything of the same size right now, and then I have an attention block here, and then I want to pass it through the attention block. Now the goal is for us to pass these vectors into the attention block and then get an output that very well represents the word and its contextual information. Now this is the role of the attention. We start with a vector, we end with a vector. Now what really happens in the plane attention is that let's consider that these words as ABC, or let's just take the same word. Let's say this is good, and what we really do when we want to calculate, when we want to go all the way from here to here, is that for every word from the initial representation we get a query vector, a key vector, and a value vector. Now you can watch the other video to know how we get to these query, key, and value vectors, but here what we do is take this query vector, multiply it with every other key vector, and then we go on to scale it with the root of the dimension. Consider 5 and 2 as the dimension of the vector right now, and then we pass it through a softmax function, and we end up with 3 probabilities that add up to 1. And what we do is multiply each of the value vector with the corresponding probability, and this is for just the word this. So we end up let's say this is v1, v2, and v3. We end up with we concatenate the 3 value vectors and end up with the resulting vector. So this vector is this one. So this way we repeat this process for all the other words and get a final representation, a representation that's been passed through the attention block. Now let's derive the multi-headed attention from this. So let me just go down here. So let's say let's take the same example. This is good, and let me draw the same thing as the so we have a query vector, a key vector, and a value vector. Now let's not really focus on the dimension of the vector and the number of heads. Let's not say let's not talk about the numbers right now, but let's say I'm calculating a representation with 2 heads. Now I want to calculate a representation with 2 heads. What I would do is first get the query, key, and value vectors, and then I would go on to separating these. Now let's just for the sake of this example, let's consider this vector is of size 10. Okay, every vector is of size 10. What I do is I split it into 5 and 5 because we want 2 heads, right? So 5 and 5 equal size. So I split this into Q1 and Q2. Similarly for this, and then I split the keys too into K1 and K2. I'll split the values into V1 and V2. Now similarly, I'll be doing a split for all the other vectors too. Now we have a subset of the big vector. Now let's go to the side here. What I would do is lay down these three, like let's say Q1, Q1, Q1. Now when I talk about Q1, like three Q1s, these are Q1s from the three words. This is good. Now these Q1s are coming from, like we're taking these left-handed side ones, like we're taking all the three ones, and like similarly we're taking the key and value vectors that's on the left, okay, this side. And what we're doing is we just lay them on, and then we can like check with the example here of how we did the calculations. This way of how we did it for the normal attention, we do it in a similar way where we take the key vector and multiply it with the, we take the query vector and multiply it with the key vectors, and then we go on to scaling it and then passing it through a softmax, and then we get like three probabilities. I mean three because in this case they're like three words, and then we multiply it with like the corresponding value vectors. Let's say this into x, this into y, and this into z, and then we concatenate this. Now similarly, this way I would do it for Q1, Q2, for Q2, and similarly K2 and V2. This way I would like calculate a representation for these two. So now I have like two representations. This is for like the first head, and I would get another representation for the second head. Now this would be of size 5. Remember how initially our vector was of size 10 and then we split into two heads. So each of these vectors would be of size 5, and what we do is concatenate them, like just like place them side by side, and this would be a vector of size 10, but like this comes from here and this comes from here. So this is how multi-headed attention happens and works. So in the original transformer paper, if you look at it, the vector size for any word is 5 and 2, and they consider 8 heads. So what they do is like calculate a vector of size 64 each into 8 times, and then just bring everything together to form a vector, like to form a vector of size 5 and 2, back to 5 and 2. Now why, let's talk about the intuition. This is the application part, but like why do we need multi-headed representation? Well, on the base, the way I think of it is like it works on the base, it works better than the plane attention that we're talking about. So apart from that, like the second reason would be that, let's say this is a vector, right? Initially you would just like calculate the attention value for this, and that would be like one big value. But now you're dividing it into chunks, let's say 3 or 4 or 8 or whatever it is. But like always remember that like the number of heads should perfectly divide the dimension of the vector you're talking about, because each vector should be of the same size. Now let's say I divide this into like I cannot divide into 3 heads, like just say 2 heads. And why do we divide it into multiple heads? Like the way I think of it is that, let's say we have a vector here, 3 vectors, like 3 heads, and I could like represent one aspect with this, I could represent another aspect with this, and the third aspect with this. And when I concatenate these 3, I would have like 3 different aspects, like, you know, 3 vectors representing 3 different things. That makes my representation even richer, better than having just one representation. Now this is a way I would like to think about it. Let me know if you have any comments. Thank you for tuning in. I'll see you in the next video.